Hello, my name is Arnold, and I'm here today to give a presentation on the heat treatment in United States tank armor. Firstly, we must discuss what are United States tanks made of. For the majority of the time the US has been making tanks, especially since World War I, they've been using rolled homogeneous steel to make their tanks. This steel provides a great combination between hardness and ductility, and the reason for this is mainly because of the way it is heat treated. And this rolled homogeneous steel oftentimes proved to be better than enemy steels used in their tanks, specifically the German Krupp steel, which often was too brittle to be effective. Now, rolled homogeneous steel is mainly made of a low carbon steel alloy, which was mainly nickel, chromium, and molybdenum. Now, the composition of the steel is 0.26% carbon, 3.25% nickel, 1.45% chromium, 0.55% molybdenum, 0.4 magnesium, 0.4 silicon, and a few impurities, and of course the rest being made of iron. The optimal hardness for this tank armor is very important because too hard and it's too brittle, and not hard enough and it won't stop any shells. Now, the United States Army Research Laboratory found that the two best hardness levels were 40 HRC and 48 HRC. The 40 HRC hardness was found to be best for overall protection and was great against fracture resistance, or it had great fracture resistance. The 48 HRC hardness was found to be best against armor-piercing rounds, but it gave up a little bit of its ductility and fracture resistance. Now, the process for heat treatment first begins with bringing the low carbon steel to a temperature of 1650 Fahrenheit to austenize it. And then after reaching this temperature, you must rapidly water quench the steel to bring it down to a relatively low temperature, leaving you with a martensite microstructure, which is a very hard but brittle steel. And to improve the ductility of this, we must now temper the steel. And if you want to reach a hardness of 40 HRC, you would have to temper the steel at 985 degrees Fahrenheit, which gives the steel a great combination of hardness and ductility. And to reach a hardness of 48 HRC, you would have to temper the steel at 425 degrees Fahrenheit. And it's a little less ductile than the 40 HRC, but it is much harder and provides protection against armor piercing. So in conclusion, after all the heat treatment, you have a great steel for tank armor. And this rolled homogeneous steel has done wonders for the US Army over the decades, going back to World War I. And without it, the United States tank production would be in a bad state.